discrete time Fourier transform of a discrete time non-periodic signal. So let's consider a discrete time non-periodic signal as x of n and its Fourier transform, that is discrete time Fourier transform is x of e raised to j omega. It has two equations, again the one synthesis and another one is the analysis equation. Let's see the synthesis equation. The synthesis equation is given by x of n is equal to 1 divided by 2 pi integration over the interval 2 pi x of e raised to j omega into e raised to j omega n into d omega. It's the synthesis equation. So it's a synthesis equation. Then let's see what is the analysis equation. The analysis equation is equal to x of e raised to j omega. X of e raised to j omega is equal to summation n is equal to minus infinity to plus infinity x of n e raised to j omega n. So discrete time Fourier transform, synthesis and analysis equations are here. So the synthesis equation says that we have whatever is the discrete time Fourier transform of the signal x of n is there, that is the continuous form. So x of e raised to j omega is summation, because our x of n is the discrete time signal, so there has to be a summation. But the discrete time Fourier transform of a discrete time non-periodic signal is continuous version. So let's see some of its properties. The properties of DTFT are of course linearity, time shift, frequency shift and so on. And as we have proved the properties with respect to the Fourier series and with Fourier transform. So the proof of these properties I'll leave as an exercise, because this already the things are there available, just you have to go on putting in that equation and you'll get those values. So the time shift, again x of t minus t naught it was, now it is x of n minus n naught. Similarly frequency shift, and we have differentiation, frequency differentiation as it was in the Fourier transform. Then summation, convolution is there. The summation is new one. Let's see what the summation gives. The summation, if x of n and x of e raised to j omega are the discrete time Fourier transform pairs of time domain and frequency domain, then summation k is equal to minus infinity to n x of k, means x of k signals summation, like we have x of minus infinity, x of again so on up till x of n. Then it's discrete time Fourier transform y of e raised to j omega, y of n's DTFT y of e raised to j omega is nothing but x of e raised to j omega divided by 1 minus e raised to minus j omega plus pi into x of e raised to j0 summation k from minus infinity to plus infinity del of omega minus 2 pi k. So this is proven with the condition. So we know that summation is the reverse process of differentiating. The summation operation of x of n yields y of n, whereas difference operation on y of n yields x of n. So x of n is equal to y of n minus y of n minus y of n minus y of n minus 1 is equal to x of n, because y of n is the output of x of n and x of n can be viewed as the output of y of n minus 1. So y of n minus y of n minus 1 is equal to x of n. So when we take the dtft of this signal, we get x of e raised to j omega, y of e raised to j omega minus y of n minus 1. Its dtft is e raised to minus j omega by the time shift property y of e raised to j omega. So as we are in need of y of e raised to j omega, we'll write it as the ratio of x of e raised to j omega and this 1 minus e raised to minus j omega. But from this equation we cannot find when omega is equal to 0, like y of e raised to j 0 cannot be found, because when j 0 we put, it becomes 1. E raised to 0 will make it as, will be 1, and 1 minus 1 would be 0, which will go to infinity. So to find that one, except that omega is equal to 0, we can find any value. So we write this one as x of e raised to, this ratio as it is, but we are well aware that we can't find y of e raised to j 0. So we add pi into x of e raised to j 0 into del of omega. So where omega is between minus pi to plus pi. This first term is assumed to be 0. This term is assumed to be 0 for omega is equal to 0. Since y of e raised to j omega is periodic with period 2 pi as per the equation we saw, as per this equation it is assumed to be periodic with period 2 pi. So we write this one, this equation, as this minus this plus pi x of e raised to j 0 summation k from minus infinity to plus infinity del of omega minus 2 pi k, where k runs from minus infinity to plus infinity, which will be the complete definition. So this is the summation property, and the summation property proof is the followed. So this one itself. So I hope the next property is convolution. You know how to do these all properties. Only the summation was new for it. So we have seen that one. Then the Pascal's property is there. Then let's see the problems. Let's solve the first problem, that is find the dtft of the signal x of n is equal to alpha raised to n u of n, wherein the alpha, magnitude of alpha, is less than 1, and we need to draw the magnitude spectrum of this one. So let's find this. So we note down the problem, and the formula we have to use is the analysis formula. So x of e raised to j omega is this one. We'll substitute the value of this x of n. So when we substitute, we know that alpha raised to n is multiplied with u of n. So the summation runs from n is equal to 0 to infinity instead of from minus infinity to plus infinity. It is alpha raised to n e raised to minus j omega n. Alpha raised to n e raised to minus j omega n. Now to solve this one, we have to combine these two terms. So let's write inside the summation n is equal to 0 to infinity as it is, but in the summation, let's write it as alpha into e raised to minus j omega, and this to the power n. And we have to use the formula which we are known with. So we know that there is a formula, summation k is equal to 0 to infinity alpha raised to k. If alpha is less than 1, then we can approximate it to 1 by 1 minus alpha. Now here this alpha, the magnitude of this one is less than 1. So anything, now this magnitude is 1 into a factor that is less than 1 will make it as surely a value that is less than 1. So we can write this one as equal to 1 divided by 1 minus alpha into e raised to minus j omega. Alpha into e raised to minus j omega. This we can write as 1 divided by 1 minus this alpha into the power minus j omega is nothing but cos of omega minus j sine of omega. So which can be written as in this fashion, and the magnitude of this becomes, so we have 1 minus alpha into cos of omega as the real term, and this minus and minus plus j sine of omega as the imaginary term. So we'll write in this fashion. So we need to consider as magnitude of alpha is less than 1 is given. So alpha can be greater than 0 or even it can be less than 0. So first we consider when alpha is greater than 0. When alpha is greater than 0, let's put omega as a 0. When we put omega as a 0 here, we get this alpha cos of 0. So which will make this real term as a 0, and this alpha sine of omega, this as 0. So we get, so this sine term has gone 0, but this is 1, so it will be 1 by root of 1 minus alpha. So we get when omega is equal to, this is our omega, when it is a 0, we get 1 by root of 1 minus alpha, the square, which will 1 minus alpha we get. So let's mark it here. So similarly, when we take this, when omega is equal to pi, we get 1 minus alpha. This cos of pi would be minus 1. So we get 1 by root of 1 minus this minus of minus, that is plus alpha square. So alpha the whole square, and this omega is equal to again 0. So we get when omega is equal to pi, we get the value as 1 divided by 1 minus, 1 by 1 plus alpha, and certainly 1 by 1 plus alpha is larger than 1 by 1 minus alpha. So we get, let's say, this quantity, this value here, and again when it becomes 2 pi, we get the same value what we got it for omega is equal to 0, and when it is again 3 pi, we get the same value what we got it for pi. So it would be this kind of a signal. In this way our output varies, so it would be in this way. And even when we put this as minus pi, the same thing will be observed, because cos is a even function. So we get when it is minus pi, then also we get 1 divided by 1 plus alpha, and again when we make it as 2 pi, we get this value. So in this way our graph would be there. And similarly, when the choices, when alpha is less than 1, when alpha is less than 1 means it is negative. When it is negative, in those cases, even after substituting omega is equal to 0, we are getting 1 by 1 minus alpha, and even when omega is pi, we are getting 1 by 1 plus alpha. But the value is negative, which makes it in this way, which makes it, so we get 1 by 1 minus alpha, but this value would be lesser than, so let's represent this value here, and this would be lesser than we get for, what is that, omega is equal to pi. So 1 by 1 minus alpha is being treated as 1 by 1 plus alpha, and because alpha is negative, and 1 by 1 plus alpha is treated as 1 by 1 minus alpha, so this would be 1 by 1 plus alpha. Again, in this way the graph would be that. So it is the property of our discrete time periodic signal, discrete time Fourier transform is, the outcome is a periodic signal, and which will be running with 2 pi as its period. So even though x of n is non-periodic, but the output x of e raised to j omega is periodic with fundamental time interval 2 pi as omega is equal to. Let's see the phase of the signal. The phase is given by x of e raised to j omega, the phase. So the same can be written as, it is 1 minus, we know this is the real factor, so it is 1 minus alpha cos of omega, and this minus of minus plus j alpha sine of omega. So when we write this, the numerator is contributing, it is 1 plus j 0, so no contributing, it's not contributing any angle. Even this 1 minus alpha cos of omega and this. So let's write tan inverse of, so this is in the denominator, let's take it above. So minus tan inverse of alpha sine omega 1 minus alpha cos omega. When omega is equal to different values, we need to plot. So for that we'll consider alpha as greater than 0. When alpha is greater than 0, so let's substitute alpha, omega is equal to 0 here. When omega is a 0, sine of 0 is a 0, so we get 0 value. When omega is pi by 2, we get this one as alpha into sine of pi by 2 is nothing but minus tan inverse of alpha. This omega is alpha pi by 2, means we get just alpha tan inverse of, and cos of pi by 2 would make it as 0, so it is just tan inverse of alpha, but with a minus sign. When we take omega is equal to pi, again we get 0. Now when we take this one as 3 pi by 2, omega as 3 pi by 2, then sine of 3 pi by 2 would be minus. So minus of minus will make it as plus, so that time we get tan inverse of alpha again. So whatever is the value of alpha, the same, means it is this kind of a thing. So at pi by 2 it takes minus the tan inverse of alpha value, and again it increases at pi, again it becomes 0, and it takes the positive values when the angle, the value of omega becomes greater than pi. So it goes in this fashion, and when omega is negative, the things would be reversed. When it is 0, no problem, same, but when it is minus pi by 2, then what happens is it is 1 only, and we get this sine of minus pi by 2 will sine of minus. So minus we take, minus of minus would be plus, so which will make it as plus. So it would be this kind of a curve for alpha greater than 0. If alpha is less than 0, let's draw it with the other color. If alpha is less than 0, then the things would be, this would be minus. So we get a reverse kind, the similar curve, but it would be reversed. It takes higher value and it goes to 0. It would be just reverse, because we get, wherever we are getting minus, we get plus that. and where we are getting plus, we get minus over there. So the graph would be just a tangential graph itself, but it is in this fashion. It goes positive in case of alpha less than 0. If alpha is greater than 0, it would be a reverse. So it would be going in this fashion. So I hope you all understood this problem. Let's see the further problems in the next class.